Hey guys, welcome back to another video. In this, we're going to be learning about the unit circle and the radian measure. This is chapter number 8 from additional mathematics. Okay, so let's begin with the radian measure. There's a definition over here, but it's not really important to know. You just need to know what a radian is, and that's fine. You don't have to really know the definition, but I'll read it out. It's the angle subtended at the center by an arc of length 1 unit in a unit circle is said to have a measure of 1 radian. I mean, you can memorize it, but it's not that important. It just says that. I mean, I'll show you what it actually means. Okay, so if this is a circle, it's gonna have a radius, let's say 1 unit, and then the arc length, the length of the arc will also be 1 unit. When this is the case, then there'll be some angle here. And the angle subtended over here would be 1 radian. So this is the definition of 1 radian. If you visualize it, it's much easier to remember the definition. Now that we know what 1 radian is, we're going to move on. So the symbol used to denote the radian measure is either rad or the small c, this one. So we can either use this or this. Okay, so now let's move on. So pi radians equals to 100 degrees. So that's the conversion. that's the conversion factor. So if we want to convert from degrees to radians, we're supposed to multiply by pi divided by 180. And if we're converting from radians to degrees, it's going to be, we're going to multiply it by 180 by pi. Okay, this is pretty simple. Let's move on to a few questions. So this is extremely important, and so is this. If the concept is clear, let's move on to a few questions. So we're supposed to convert degrees into radians. So let's work this out. Have your calculators with you. So yeah. So if we want to convert from degrees to radians, we have to multiply by pi and divide by 180. So let's do the first one. So 90 into pi divided by 180. This would be pi by 2 radians. This is our answer for the first question. The second one, so that would be 30 into pi by 180. That's gonna be pi by 6 radians. This is our second answer. And the third one, so 135 into pi by 180. So let me see how much that is. That's 3 by 4 pi radians. So these are the answers. So let's verify whether that's right. Pi by 2, pi by 6, and 3 pi by 4. Now that the first question is over, let's solve the second one. So we have to convert the following radian measures to degrees. Okay, so in order to convert from radians to degree, we have to multiply by this factor. Okay, so let's solve the first one. So 7 by 9 pi into 180 by pi. The pi and pi get cancelled. Then 9, this will be 20. Yeah, 20. So that will be 140 degrees. So this is our first answer. And then 3 by 5 pi into 180 by pi. The pi gets cancelled. And then this will be 36. And that's 90 plus 18. So that's 108 degrees. Second answer. And now let's solve the last one. So pi by 10 into 180 by pi. The pi and pi gets cancelled and we're left with 18 degrees. So let's see if the answer is correct. 140, 108 and 18. Now take a couple of minutes to solve the next one. So you have to convert the following angles, which are in degrees, you have to convert them into radians. So take a few minutes and I will reveal the answers. Okay, so if you're finished, I will reveal the answers. If not, pause the video right now and try to solve this. So these are the answers. Pi by 4, pi by 2, 3 pi by 4, pi, 5 pi by 4, 3 pi by 2, 7 pi by 4, and 2 pi. This isn't really part of the syllabus, but it will be really important to know. So first, let's look at the radius. So it's the line segment that connects the center of the circle to any point on the circumference. The circumference would be this. So it's a line segment that connects the center of a circle and a point on the circumference. Next is a sector. So it's the portion of a circular region enclosed by two radii, 1 and 2, and the corresponding arc. So that's what a sector means. That means that it consists of two radii and the arc. So this would be a sector. And then there's something called as the minor sector and the major sector. A sector is a minor sector if it involves less than half of the circle. So this would be considered as a minor sector, and this would be the major sector. So yeah. And then the major sector involves more than half of the circle. So this is the major sector and this is the minor sector. Next, we're going to look at a chord. We're looking at this because in order to understand what a segment is, we first need to know what a chord is. So it's a segment with endpoints on the circle. So it has 1 and 2 endpoints. And yeah, so it's just a segment with endpoints on the circle. So this is a chord. And now let's move on to what a segment is. So by definition, it is a region bounded by a chord. So this would be the chord and a corresponding arc lying between the chord's endpoint. It's somewhat similar to a sector and radius. So the relationship between a radius and a sector is very similar to the one of the chord and the segment. So yeah, so how the way these two are related, these two are also related in the same way. And then we all know that the diameter is either twice the radius, or it like connects the two endpoints and meets the center of the circle. So that's what the diameter means. And now let's move on to what an arc is. So, so it's the portion of the edge of the circle defined by two endpoints. So yeah, two endpoints, and yeah. And then similar to how we have a major sector and a minor sector, we also have something called as a minor arc and something called as the major arc. So if the arc measures less than 180 degrees, then it's a minor arc. But if the angle is greater than 180, that means it's the major arc. So this would be the minor arc, and this would be the no, this would be the minor, and this would be the major arc. Okay, and the circumference is the outer part of the circle. Yeah, and finally we come to tangents. So it's a line that intersects the circle at exactly one point. So over here it cuts the circle at exactly one point. So, and then this forms 180 degrees. I mean, this forms 90 degrees. I'll show you 1 second. Okay, so a tangent will form a right angle here. When you connect the point that it intersects the circle at to the center of the circle, you can form a right angle. So this is a very important point to know. It will come up frequently. Okay, so now that we know what the parts of the circle are, let's move on to the arc length. Okay, so we know what an arc is, but how do we find the length of the arc? So let's just look at this diagram first. So in the diagram, the arc length AB is L. So yeah, and then the angle measured in radians. This is extremely important. If this is in degrees, your calculation and your answer will be completely wrong. So this has to be in radians. So we need to know the angle and the radius in order to find the arc length. So we can use the ratio to obtain, so it's arc length by circumference equals to pi, the theta by 2 pi. This makes sense, right? Because the ratio will remain the same from like the main angle to the smaller angle. The ratio will be the same to the arc length as to the circumference. So and now we can substitute the values in. So arc length will be L, the circumference will be 2 pi r, and this would be theta by 2 pi. We can cancel these two out, so will be theta r. And we can do the same in terms of degrees. So if we use the same formula, then we get the formula as theta by 360 into 2 pi r. So yeah, so for theta in radians, the arc length would be theta r, and then if it's in degrees, then the arc length will be theta by 360 to 2 pi r. So now let's move on to the area of the sector. So in the diagram, the area of the minor sector XOY is shaded. So we can see that, and we know that the angle is measured in radians. So when we use the same ratio, a similar ratio of the area of the sector divided by the area of this circle will be theta by 2 pi. So if we substitute the values in, we get this, which is half theta r squared. So this is in terms of radians, and in degrees it would be theta by 360 into pi r squared. Okay, so we usually use radians in most of the questions, so make sure that you remember the following formulas. This is extremely important. Yeah. Okay, now let's solve a few questions. Let's solve the first question. So let's read it. So use radians to find the arc length and the area of a sector of a circle of radius 9 cm and angle 7 pi by 4. So we know that L equals to theta r. So we'll substitute the values, which is 63 by 4 pi, which is 49.48. We'll round it to 49.5 cm. Okay, now let's find the area. Area would be half pi r squared. Theta, sorry, my bad. Half theta r squared. So this will be half into 7 pi by 4 into 9 squared, which is 567 by 8 pi cm squared, which is 222.66, which will round off to 223 cm squared. So let's check our answer. So it's 49.5 and 223 cm squared. So we got our answer. Now let's do the next one. So it has radius of 4.93 and then angle of 4.67 radians. So L is theta r. So 4.93 into 4.67, which is 23.0231. We'll just write 23.0 cm. Now let's find the area. So we use the same formula. A equals to half theta r squared. So half into 4.67 into 4.93 whole squared. Now let's plug this into the calculator. We get 56.7519415 cm squared. And we can round this off to 56.8 cm squared. It's our final answer. So let's verify this. Yes, that is our answer. So now let's move on to the next question. So a sector has an angle of 1.19 radians and an area of 20.8 cm squared. So we have to find the radius. Okay, so let's write down all the information we have. Okay, so let's write down all the information we have. So angle, so theta equals to 1.19, and area, which is A, is 20.8 cm squared. So we know that area equals to 1 divided by 2 theta r squared. So r squared is 2a by theta, and r would be the square root of 2a by theta. We're not taking plus or minus because length cannot be a negative value. So it's going to have to be the positive value. Now let's substitute the values in. We get 5.91252768, which is 5.9 cm. Okay, 5.91. Okay, so that's our answer. And now we have to find the perimeter of the sector, I think. Probably. Yeah, so to find the perimeter, we have to know okay, let's draw the sector. Ignore the bad drawing, but yeah. So this is r, theta, r. So that would be the perimeter. So r plus theta, r. We'll take r common, so. And now let's use the exact value in the calculator. Let's find this. It's 18.860962. We can write 18.9 cm. 18.9 cm. Let's solve the final question. So we have to find theta and a, which is area. Okay, so we know the arc length, we know the radius. So we put in the values here. So 6 equals to theta into 8. So theta would be 6 by 8, which is 3 by 4 radians. Now let's use the area formula, which is half theta r squared. We know that theta is 3 by 4 and r is 8, so 8 squared. So this gets cancelled, so this is just 3 into 8, which is 24 cm squared. So now let's see the answer. Yes, so 3 by 4 and 24. Okay, now let's solve this one. L equals to r theta, same formula, and L is 8.4 and theta we don't know, r is 5. Theta is 42 by 25, which is 1.68 radian. Now let's find the area. Half theta r squared. So half into 1.68 into 5 squared. That's 21. 21 cm squared. So we got the answer. Okay, now let's move on to the next topic. So from now on, it's going to be a lot of theory. So first we'll learn about angles and direction. So you might have thought that angles are only positive. Well, that's not true. So let's look at the thing. So angle measurement. Suppose P lies anywhere on the unit circle and here. And A is 1, 0. So 1, 0. Let theta be the angle measured from OA on the positive axis. So theta is positive for anti-clockwise rotations and negative for clockwise rotations. Okay, so this may seem complicated, but all you need to know is this. So if you make an angle with respect to the x-axis and you go anti-clockwise, then this is going to be plus. The angle is going to be positive. So this is the positive direction, this way. And then if you go the other way around, it's going to be the negative direction. So let me draw something. This is going to be plus 30 degrees, and this is going to be negative 30 degrees. And also, since this is a periodic cycle, so if this is the angle, then this is also equal to negative 330 degrees. This may seem very confusing, but you just need to believe it. The way we derive this is pretty simple. We just have to subtract 360 from it. We get negative 330. So if we add 360, it's going to be 330. So negative 30 is also 330 degrees. This only works because it's a circle and it keeps repeating, So that's why this is true for angles. Okay. So if theta is this, then this angle would be negative 150 degrees. So now that we've learned about the direction and angles, let's move on to another topic. So this one. So for theta in radians, and k is an integer, positive integer. This is extremely important. It has to be a positive integer value. So this is going to be, so cos of theta plus 2k pi is cos theta. Okay, now you might be very confused right now, but just think about it. This is a circle, right? This would be 360 degrees, right? What comes after that? Just imagine you go around the circle once completely and a little more. Let's say this is 10 degrees. But you have gone around 360 plus 10 degrees, which is 370, but it is also 10 degrees. Now, is that clear? So, I hope it makes sense, So this will basically be a multiple of either 2 pi or 360 degrees. So yeah, it also applies for sine 2. So let's say 100, what would this also equal to? This will also equal to minus 360, which is 750 degrees. It's one and the same. And then if you keep subtracting 360 from it, it's going to be 390, which is greater than 360. So if you travel 360 degrees and more, 30 more degrees, then you'd complete that. So we can derive that 30 degrees is also equal to 1110 degrees. If you're not very sure, you're still in denial, just take out your calculator and type cos 1110 and subtract that by cos 30. You get 0. You can try it for how many other numbers you want. You can use a different value and then try to derive this or anything. Just try it out. use like angles like, I don't know, 5,675, and then subtract 360 from it. Keep doing that and then find the value of cos of that particular angle. And if you get the same, then this concept is right. Yeah, you can try that out so that you're like very sure. Okay. And now we're moving on to like sine and cosine. For that, we just need to identify certain things. So first of all, you need to know what a hypotenuse is. It's gonna be this line. We've learned this in like Pythagoras theorem in like sixth grade, fifth grade. So yeah. And if this is the angle, then the opposite side will be opposite of it. So this would be the opposite side, and this would be the adjacent side. Whatever is not the opposite, it's going to be the adjacent side. Okay, now that we know these three terms, let's apply it to another triangle with a different angle. So the angle is placed here and not here. So this would be the opposite side. This would be the adjacent side. And this would be the hypotenuse. So if this is clear, let's move on to sine and cosine. Sine and cosine are just ratios. All you need to know is that they're ratios. So if you understand that, then it will be easy for you to learn the concept. Okay, so now let's look at this. So consider a point P, which is A comma B here, which lies on the unit circle in the first quadrant. So I hope you guys know what the quadrants are. This is the first quadrant, this is the second quadrant, this is the third, and this is the fourth quadrant. First, second, third, fourth, anti-clockwise, starting with the right topmost one. Okay, so it's shown here. And now if we want to find cos theta, sine theta, and tan theta, we're going to have to apply ratios. Or we're just going to divide certain things in order to find these. So first, we'll start with sine theta. So sine theta is opposite by hypotenuse. It's opposite by hypotenuse. It's going to be the same. This formula is going to be the same for any triangle that you take. So the opposite side would be B and the hypotenuse would be this. So it's going to be B by 1, which is B. So sine is opposite by hypotenuse. And cos theta would be adjacent by hypotenuse. So adjacent would be A by 1. The hypotenuse would be 1. The adjacent side would be A. So it's going to be A by 1, which is A. So sine is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Okay, I'll draw a figure here. Tell me what would be, let's say this is 5, 6. Okay, that's 3, 4, 5. What's sine theta? I'll give you 2 minutes, write down the answer, and then we'll check. So sine theta is opposite by hypotenuse. Opposite is 3 and hypotenuse is 5. So it's going to be 3 by 5. And what would be cos theta? Cos theta would be adjacent by hypotenuse. So it's going to be 4 by 5. Okay, now if that is clear, then let's move on to tan theta. Tan theta itself is a ratio of cos and sine. Yeah. So it's also sine theta by cos theta, which is tan theta. But if we want to write in terms of opposite and adjacent, we can write opposite. So tan theta would be opposite by adjacent, which is B by A, which is essentially sine by cosine, which is b by a also. So these are the ratios. It's very important to know them. So let's repeat that. Sine is opposite by hypotenuse. Cos theta is adjacent by hypotenuse. Tan theta is opposite by adjacent, which is also sine theta by cos theta. This is the thing. And now let's look at this. In general, for a point P anywhere on the unit circle, so unit circle is this, starting with the ordinal 0.0 with radius 1. So cos theta is the x-coordinate of P. That makes sense because cos theta is A, right? And sine theta is B. So obviously P would be cos theta comma sine theta for like all the points anywhere in the circumference. Okay, so now that we know what sine theta, cos theta, and tan theta are, now I'm going to show you some of my own notes that I did when I was in 10th grade, which is like about a year ago. So yeah, so trigonometric ratios of general angles. That's the topic. And now let's look at this. The notes are very detailed, but you don't really have to know so much in order to like get high marks for like this chapter. So these notes have like extra things that aren't really part of the syllabus, but it might be good for you to know. Okay, so I told you that this would be the first quadrant, this is the second quadrant, this is the third, and this is the fourth quadrant. And then this is the positive, this is the negative angle. So the angle that is made by the terminal ray, which is this, terminal means that it's gonna like move away. So yeah, from the origin, which is the initial ray. So this is the initial ray and this is the terminal ray. Can either be positive or negative. So if the terminal ray rotates in an anti-clockwise direction, it is positive. Whereas if the terminal ray rotates in a clockwise direction, it's negative. I also forgot to mention this point over here. So we know that x squared plus y squared in this case would be 1, right? Or 1 squared. So if we actually plug in these values, we'd get cos squared theta plus sine squared theta equals to 1. This is one of the trigonometric identities we're going to learn for in like the next chapter. So yeah, this is very important. So cos squared theta plus sine squared theta is 1. You need to remember that. Okay, moving on, let's come back to this topic. So 30 degrees would be negative 330 degrees and negative 30 would be 330, and this one 420 would be 60 because 420 by 360 is 60. So yeah. So 80 would also be negative 280. Okay, so this one is going to be a little complicated and out of the syllabus. So my teacher taught me this, but then you don't really have to know. You can, I mean, it's good to know, but like it won't be asked in the exam. So this part won't be asked in the exam. So the derivation will not be asked, I mean. So an x coordinate is the first element in an ordered pair. So like when you're writing coordinates, you write the x coordinate first and then the y. So it's the first element in the ordered pair. Okay, so x is also called abscissa, and then the x coordinate represents the directed distance of the something I didn't write from the y-axis, distance of something from the y-axis. And y coordinate is also called ordinate, and the y coordinate represents the directed distance of the something from the x-axis. So sine theta, okay, now let's draw the triangle here. So sine theta, this is the angle, by the way. So sine theta would be opposite by hypotenuse, which is y by r. And cos theta would be x by r, and so on. We'll learn these a little later. We'll just focus on the first three right now. So yeah, and tan theta would be y by x. Okay. And also I've made this point. Also, 2n pi plus or minus theta equals to plus or minus theta, where n is an integer because it is periodic, meaning it repeats. That's what I've told. And sine 1110 would also be sine 20. So we know that sine 90 minus theta is cos theta, and cos 90 minus theta is sine theta, and tan 90 minus theta is cot theta. So memorize this. So you'll have to memorize these. So yeah. And then I have written down the proof of it, but you don't really have to know that. And then similarly, so you don't really have to know like how to derive the thing, you just need to know it. Know like the formula. So sine 90 plus theta would be cos theta, and cos 90 plus theta would be negative sine theta. You might be confused why this is plus, this is negative. Let me show you this. So you'll have to remember this. All students trust Cambridge in order to find whether it's going to be positive or negative. So in the first quadrant, what this means is that starting from the topmost box, which is also on the right, you'll have to go in the anti-clockwise direction, assigning each quadrant the alphabet. So this would be A, so all students trust Cambridge. So A means all trigonometric functions. S would be sine, T would be tan, C would be cos. So this means that all of the ratios, all of the sine, tan, cosine will be positive in this quadrant. And in this, only sine is going to be positive, and cos and tan will be negative. In the third quadrant, tan is going to be positive, but sine and cosine are going to be negative. In the fourth and final quadrant, cos is going to be positive, and sine and tan are going to be negative. So, yeah. If you think about it, in the second quadrant, sine is going to be positive. So that's why this has a positive I don't know, coefficient. Yeah. So, and then cos 90 plus theta would be negative, because in the second quadrant, cos and tan are negative. So yeah. And then so on. And then there's a lot. I will just show you this if you want to copy. This is the next. Here we're dealing with 180 degrees. I will tell you like a rule of thumb that you can follow instead of having to memorize all of these. But for now, you could just copy these down. So this is extremely important. This means that it's in the third quadrant. This means it's in the second quadrant. And these. This is in the fourth quadrant. That's why, no, it's in the third quadrant. That's why only tan is positive. And finally, this is the fourth quadrant. So cos will be positive, the rest will be negative. And then this would be 360 minus alpha. So it's 270 plus alpha. Okay. So now that you've seen this, I will tell you a rule of thumb that you can use. So if it is the even multiples of 90, for instance, plus or minus alpha, 180 plus or minus alpha, and 360 plus or minus alpha, it will be b itself. But if it is the odd multiple of 90, for instance 90 or 270 plus or minus theta, it will be the co-ratio of it. The co-ratio will basically be sine will be cos, tan will be cot, and cosecant will be secant. So yeah, you can use this. And then in the first quadrant, all are positive. Second, it's going to be sine positive. Third is going to be tan positive. Fourth is going to be cos positive. So you can either use this or this. So all students trust Cambridge or all students take coffee. Okay, so now I will just show you a few examples on how to solve this. Okay, so let me take a screenshot of this and paste it here. This is extremely important. Okay, so now okay, so if we want to simplify cos 270 plus 30, 270 is an odd multiple, right, of 90. So it will be the co-ratio, so which is sine. So it's going to be sine 30. And this is in the fourth quadrant, so it's going to be plus. So if you plug the value of cos 300 into your calculator, you'll get 1 by 2. And this will also be 1 by 2. So this is how you use this information. And then you can like try it for like any values. So yeah. This could also be written as cos negative 60. And like you can try with various values, different trigonometric ratios, and you could try it. I'm hoping that this concept is clear. So let's move on to a few questions. So the first question states the following. Find all angles between 0 and 360 degrees with a sine of 1 by 2. So first, let's do sine inverse of 1 by 2. We get 30 degrees. So if sine theta equals to 1 by 2, then theta is sine inverse of 1 by 2, which is 30 degrees. And now if we want to find the other angle, let's first draw the table. So this is all students trust Cambridge. So we can see that sine is positive in the second quadrant. If we do 180 minus 30, because sine of 180 minus 30 is essentially sine 30, because 180 is a positive, not a positive, an even multiple of 90. So that's why this is going to remain the same, and it's going to be positive because it's in the second quadrant. Thereby we get sine 30. So therefore, theta is also equal to 180 minus 30, which is 150 degrees. So our answers are 30 degrees and 150 degrees. Moving on, so this is the second question. It's somewhat similar. So first, let's write down the equation. So it's sine theta equal to root 3 by 2. So theta is sine inverse of root 3 by 2. When we do this, we get 60 degrees. The same rule applies here. All students trust Cambridge. So sine is positive in the second quadrant. Therefore, theta equals 180 minus 60, which is 120 degrees. Okay, now the third one. So a cosine of negative 1 by 2. So cos theta equals to minus 1 by 2. So theta would be cos inverse of negative 1 by 2. We get 120 degrees. Let's draw this again. In the first and the fourth quadrant, cos is positive. So therefore, we're supposed to look at the second and the third because negative 1 by 2 is negative. So we're supposed to find a value which is in the third quadrant. Therefore, theta is 360 minus 120. Now this would lie in the third quadrant because cos 360 minus 120 degrees would be cos 120. They would be the same because this is an even multiple of 90. So yeah, therefore theta is also equal to 240 degrees. These two are the answers. Now let's solve the final part of the first question. So cos negative 1 by root 2, no wait, my bad. Cos theta equals to negative 1 by root 2. So theta will be cos inverse of negative 1 by root 2. So if we find that, we get 135 degrees. And similarly, theta would be 360 minus 135, just 225, and it lies in the third quadrant. So therefore, our answers are 135 and 225. Now that we've finished this question, now let's look at the next question. So we have to find theta if theta lies between 0 and 2 pi, and it's given that cos theta is 1 by 2. Cos theta is 1 by 2, so theta will be cos inverse of 1 divided by 2, which is 60 degrees or pi by 3 radians. We have to write this in terms of radians because that the range that they have given us, the domain, it's in radians. So therefore, one of the answers is pi by 3. And now let's draw the quadrants. So that's all students trust Cambridge. Cos is positive in the first and the fourth quadrant. So the other value of theta is 2 pi minus pi by 3. which gives us 5 pi by 3 radians. So the two answers are pi by 3 and 5 pi by 3. Okay, now let's look at the next one. It's given that sine theta is root 3 by 2. Therefore, theta is sine inverse of root 3 by 2, which is also 60 degrees or pi by 3 radians. But the second angle won't be the same. We'll look at it. So this is the reason all students trust Cambridge. And then sine is positive in the second quadrant. Therefore, the next value of theta would be pi minus pi by 3, which is 2 pi by 3. Now let's solve the last one. So cos theta is minus 1. So theta be cos inverse of minus 1, which is pi. The second angle will also be the same because 2 pi minus pi is pi. So therefore we only have one answer, which is pi. If this concept is clear, then now let's move on to the next topic, which is the reciprocal trigonometric ratios. So there are a total of 6 trigonometric ratios, which are sine, cosine, tangent, cosecant, secant, and cotangent. The short forms are, I'll write it down. The first one is sine, which we usually write as just sine. The next one is cosine, which is cos. Is tangent, which will be tan. The next one is cotangent, which will be cot. The next one is cosecant, which will be this. It's not going to be cos. And then the last one is secant, which is SEC. Sine and cosine are ratios. Tangent and cotangent are co-ratios. And secant and cosecant are co-ratios. But co-ratios and reciprocal trigonometric ratios are two different things. The reciprocal of sine would be cosecant. The reciprocal of cos would be secant. And that of tan would be cot. It just means that cosecant would be 1 by sine theta, secant would be 1 by cos theta, and cot would be 1 by tan theta. Okay, so now that we've gotten this, let's look at trigonometric identities. These are the trigonometric identities, along with cos squared theta plus sine squared theta equals to 1. So we know this one because of the unit circle. I'll show you the slide. So because of this, we know that this is indeed true. This is because the point on a circle, the circumference with respect to the origin would be P. The point P would be cos theta, comma sine theta. And if you apply the Pythagoras theorem, you'll get x squared plus y squared equals to 1 squared. And you could derive that cos squared theta plus sine squared theta is 1. Let's prove the trigonometric ratios using one of them. We have this. I'll just erase this 1 second. we have sine squared theta plus cos squared theta equals to 1. Now let's divide this equation by sine squared theta. This would be divided by sine squared theta by sine squared theta by sine squared theta. This would be 1. This would be cot. No, actually, wait, you guys don't know this yet, but one second. Okay, we know that tan theta is sine theta by cos theta, right? So what would this be? It's going to be 1 by tan theta, and what is 1 by tan theta? Cot theta. Hence, this would be 1 plus cot squared theta equals to what is 1 by sine theta? Cosecant squared theta. Secant squared theta. Hence, we derive this identity. Similar manner, let's prove the third identity. Okay. We have sine squared theta plus cos squared theta equals to 1. But now let's divide this whole equation by cos squared theta. We can write this as sine theta by cos theta whole squared plus 1, because cos squared theta divided by cos squared theta is 1. And we have 1 plus cos theta whole squared. So we know that sine by cos is tan. So it's going to be tan squared theta plus 1 equals to what's 1 by cos theta? Secant theta. So this is going to be secant squared theta. So this is how we derive the identity. So we derived this one too. So these three are really important to know. So the first one, I write all of the three here. The first one is sine squared theta plus cos squared theta equals to 1. 2, tan squared theta plus 1 equals to secant squared theta. 3, 1 plus cot squared theta is cosecant squared theta. Don't panic if you don't remember these. 1, you can derive it using the first equation. It's pretty simple to remember. But if you don't remember that too, you'll have the formula sheet. In that, you'll be given all of these identities, so you don't really have to panic or worry about it. But it's going to be easier for you to remember these. It's not that complicated. It will be really helpful if you remember them. Okay, now that I've spoken about the formula sheet, I would actually like to show you that. So if you open any paper, any past paper, you will, on the second and third page, you will have, actually on the second page, you will have this formula sheet. You're gonna get a more detailed one in AS level and A level maths. It's gonna be about like 16, 17 pages long, covering stats 1, stats 2, mechanics, pure maths 1, pure maths 2, and further maths. So first, let's just look at this. In this, we've been given the quadratic equation. We know that it's, we have already learned this. It's minus b plus or minus square root of b squared minus 4ac whole divided by 2a. It's pretty simple. If you forget, it's just look at the formula sheet. And then we have the binomial theorem, which we're going to learn soon. And we have the arithmetic series, the geometric series, These three we're gonna learn soon. We're gonna learn it in the next chapter or like the one after that. And then this is all algebra. And then we have trigonometry. This is what we're learning right now. So as I told you, we'll be given the identities. The first one, second one, third one. We already know this. It's better if you remember them. If not, then we totally have this. And then we'll have the formula for the area of the triangle, for like triangles, not area, just based on triangles. So we have the first one, the second one is called as the cosine rule. This is the sine rule, and this is just a rule. Okay, that's it. You'll be given like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You'll be given 14 formulas and make this useful, use it to your advantage. And yeah. Now let's do some questions regarding the reciprocal trigonometric ratios and the trigonometric identities. Okay, so first let's read the question. So without using a calculator, find cosecant x, secant x, and cot x. Okay, I made a mistake here, not cos, it's gonna be cot. Okay, so first we know that cosecant x is 1 by sine x. So cosecant x will be the reciprocal of this, which is 5 by 3. And then we'll move on to secant x. Okay, so first let's use the trigonometric identity. Sine squared x plus cos squared x equals to 1. So therefore, 3 by 5 whole squared plus, let's keep this as x squared equals to 1. And x squared would be 1 minus 9 minus 25. This is 16 by 25. Therefore, x is 4 by 5. Therefore, cos x is 4 by 5. Therefore, secant x would be 5 by 4. And now we have to find cot x. We know that sin x is this and cos x is this. Therefore, cot x would be cos x, which is 4 by 5, divided by 3 by 5. To 5 by 3, it's going to be 4 by 3. So our answers are 5 by 3, 5 by 4, and 4 by 3. So let's see the answer. So this would be 5 by 3, 5 by 4, and 4 by 3. So if you have understood the process, then go ahead and solve part B, and then once you're done, I'll reveal the answers. It's not too complex, it's very similar to this. And let's see. Take a few minutes to solve it. And once you're done, unpause the video. So now I'm going to reveal the answer. If you have any doubts, do let me know and I will try to answer it. So let me know in the comment section if you have any doubts. Else I'm gonna move on. Let's do the next question. Question number 2. So let me read the question. Find the other 5 trigonometric ratios if cos theta is 3 by 4, and this is extremely important, it lies in the third quadrant. Yeah, it lies in the third quadrant. No, sorry, fourth quadrant, I mean. And this is going to be extremely important because we know that only cos is going to be positive. Cos and secant are going to be positive in that quadrant. Okay, so now let's solve it. We have this, so sine squared theta plus cos squared theta is 1, right? And let's take this as x. So it's going to be x squared plus 9 by 16, which is 1. So x squared would be 7 divided by 16, I think. Let me just cross verify. Yeah. So x would be negative root 7 by 4. We're taking negative because it's in the fourth quadrant, and in the fourth quadrant sign is negative. So it's going to be negative root 7 by 4. And after we found this, we can easily find tan. We know that tan theta in this case would be sine by cos. So sine would be negative root 7 by 4, and cos is 3 by 4. These two get cancelled and we're left with negative root 7 by 3. This was pretty simple. And now it's just taking the reciprocal of the things that we have already found. So cosecant x, which is the reciprocal of sine x, cosecant theta, would be negative 4 by root 7. Secant theta would be the reciprocal of cos theta, which is 4 by 3. And then cot theta would be the reciprocal of tan theta, which would be 3 minus 3 by root 7. So these are the answers. This, not that, 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 and that. Let's see. Yes, we got this. We got this. We got this. Yes, the answers are correct. With this, we're done with this chapter. I hope that this video is helpful. Keep practicing past papers and keep practicing all the questions that you can find online. You can solve the textbook questions, and yeah, just keep practicing and make sure you have the concepts right, and then go ahead and solve the questions. If you found this helpful, do like and subscribe, share it with your friends, and thank you.